Welcome to the Keep It Simple Astronomy channel, to the live streaming. I hope you're having a great weekend. And today I have the 8-inch outside. I will show you. Here it is. It's outside. I have also the all-sky camera, so you will see it a bit from the all-sky camera with the ZWO 224, and the camera I'm using in the 8-inch today is the ZWO 294. So it is over an equatorial platform, as I always use. For the people that don't know, it's to track the sky and allow me to image the objects. Now I have exciting news, of course. I got this. This was my LED light until now, right here near my backyard, and at the right I have it removed by the local authorities. It's great because now I have a beautiful sky in all the... I will show you. We will open first the all-sky camera. It was a thing that I was not hoping too much, but I had a good guy, a politician, incredible. One don't have hope in politicians, but this one was close to the citizen. It's not my friend, it's just a politician, a local one, that cared for my problem. I said to them, I sent letters to all the institutions asking for removing that, to change the LED light by for an old one, sodium, the yellow ones, which is better to, at least is not so bad. And the guy came here, he said a few weeks and it will be solved. Okay. I received from responses from other institutions saying that it was impossible to do that. But this guy made some calls and said to me that in a few weeks it will be solved, and it was true. He arrived here one day after 3 weeks, more or less. I received a phone call in the morning. Hey, I'm at your door. It's me, I'm at your door, and we are waiting for the technicians to solve that. And I went outside, and in some minutes I will also show you these guys with a machine. You see the guy with a machine. It was a truck with this elevator, something, I don't know. And they removed it all. He said to me, the thing is, maybe this could be helpful for someone. My argument was that we couldn't sleep because the light was so strong. It's a modern LED light. It behaves like it's day, you know. And when he was here with me waiting for the guys, just for the sake of the conversation, I told him that I will benefit also from this removal, because I work with telescopes. It's one of my jobs, and it's true, because I work with YouTube, so with telescopes, it's true. I didn't lie. And the guy said, oh yes, oh, that's cool. I don't know that, but that's cool. If you want, I tell the guys to remove the LED light, and you don't have to change it. We just remove it. And I said, of course, I said yes. And I was lucky. Well, now I have a beautiful sky. You benefit also because I will be allowed to to capture more objects in the sky. Unfortunately, today it's windy, but I placed my 8-inch because of that. I wanted to work with a 12-inch today, but it's too windy. I will open the all sky while we are talking. All sky, I have this in a sequence. So lucky times for me. You see the all sky? Look, what's this? A satellite? No, it's a plane. For your information, I live in the south of Portugal. This is like Miami here in a smaller scale. We live from tourism here, and we have now, of course, loads of planes messing with the sky. But fortunately, or hopefully, will not pass through the camera. But they are always passing now. It's summer. Now, we can see here, let me change the exposure to make it brighter. It's 1 second, and I'm changing to 2 seconds. You can see, look, the Milky Way. Amazing. And the plane. Here, you see? Unfortunately, this is the place where I have a small city, my city, and it has this glow. Has the all sky camera. This is important. The all sky camera don't have don't benefit from a infrared filter. I can't place a filter with the all sky camera. I tried with a very tiny filter. I tried to place it, but it's not. I didn't get it because of the focus, and it stay close to the. I could get focus, but it stays so close to the sensor that was messing with the sensor. I didn't want to use it. So if we change the exposure, this is good for the people that have the 224, the ZWO 224, or other that came with. I'm cranking up the gain. 350, 40. 400, you see how we can see the Milky Way already? That's very nice. I'm all on Bortle 5. I will crank up the gain a bit. You see? This greenish tint that you see, it's because I don't have the infrared filter with this camera. Another thing, you can see my tail rod, the holder, this a tree bracket. It's like getting light. This is not the common light because I don't have the LED now. This light is from security cameras I have. So they don't mess with the telescope because I use always some kind of infrared or an infrared filter, or in this case I'm using an infrared filter with this setup. But with a 12-inch and the Nexus, Stars on the Nexus, I use the Bader Neodymium, which is a bit more stronger and cuts a bit of this glow near the Milky Way. You see, it's the glow of the city. It's more greenish. If I could place an infrared filter, it would be less greenish. Now I will see who is in the chat. Hello Quasar. Welcome. Tahir. Hukmak, welcome. Good evening. Steven Bombardieri from Australia. Very nice place to watch the sky. Incredible place. Yes, just for me. This was I was perseverant and I did nothing to. My plan B was to let I have a tree growing near the LED, and I was waiting for about 1 or 2 years. The tree would cut a bit behind the LED, but it was not enough. Those LEDs, those modern LEDs, you know better than me. They are directional, but they don't. They scatter the light, or I don't know. The light goes all over the place, and it's awful. Now it's very, very nice, very nice. I'm giving a little bit of time because I want to catch the Eagle Nebula with the Pillars of Creation, and it's a bit low, so we have time. You will see the power of the 8-inch. Oh, very nice. Lucky you also. Good news, David. Davide. Good news. The 8-inch, I hope you have tracking. Otherwise, you can use it for planets anyway. From Portugal. Olá, Carlos. Welcome. Yes. Yes, Steven. I mean, mine is IR UV. It's supposed to be the best. I love this filter. It works very well. It's the Bader infrared and ultraviolet cut filter, L filter. It's a very nice one because it cuts. It has I think it's 98%, something like that. It's stronger than the others, the cheaper ones. But I use this filter for this setup, and I will use the Bader neodymium for the other setup. I don't like to be always changing. Besides, when I change filters, sometimes I put the finger, I have to clean it. It's an hassle. Germany, it will be at yes. I've been watching the Eagle Nebula, the Eagle, the Lagoon. You saw the picture I had of the Lagoon Nebula with the stars on the Nexus. Incredible, the best picture of my life until now from the Lagoon. Now I will point the telescope. I just tell you something, just to clarify. Now I'm working with AstroArt, this logo that you see here, sponsored by AstroArt. Nothing will change, basically. The only thing is that you will see sometimes in my videos the logo, and in my live streams will be also here always the logo, because they are very nice guys. They are from Finland. This serves only Europe. They have good prices. They liked me, I liked them. We talk and we made a deal, and it's like that. We live like that, and I like to deal with good people, good people. I don't want to deal with crap. To put materials in. I will just use the materials I like, and I use. Thank you, Baki. Yes, I hope you're having a great Saturday night. We will point the telescope right now. Hold on. I will leave the ticket for the people to know. And I will remove this. Okay. Hold on. I have to... Let's take this... Let's open the SharpCap first. Another SharpCap. You know that you can use... you can open two SharpCaps at the same time. I'm using one with the All Sky and another one that I'm opening now. You see? I've upgraded just today because they released a new version to 94. I will just click the button for the platform to track the sky. It's not tracking, as you can see. I'm using the focal reducer. This is another important thing to tell you. From now on, if any of you want to know, have a focal reducer, a camera and a telescope, and want to know how to use it, the numbers I have here, I made this just for you. I will have this always, so in a stream, if someone asks me, like in the last stream, it was Megalodonte. It has a 462 ZWO. If you are here, Megalodonty, you say that we just have to insert here the values, you see, and it gives the old arc second per pixel, the F, the ratio, the focal ratio, and the new one. In this case, I'm using aperture 200, focal length 1200, pixel size, it's the ZWO 294, so I inserted 4.63. Then the distance from the sensor to flange. This is because the ZWO has that black thing that people make some confusion. In this case, it's the ZWO 224. It's this one. You see the sensor. It's here. The flange to sensor in the 224. It's 5 millimeters. In the 294, it's 6.5. I just place here 6.5. 6.5. Then flange to spacers. It's that black thing we have, and then we place here the spacers measurements, and then it gives us the total. I have here the 21.5. It's all the distance from the flange to the focal reducer. Then we have to add 6 millimeters from the focal reducer thread down. It's 6 millimeters. They consider it's for the optical part, the lens. They have here. This image is, I think it's a Gina Astro. I'm not sure if it's a Gina or what's the name? I don't remember. It's an American site. Then you see, you come here. I had the original telescope. It's f6, which means it gave me 0.8 of arc second per pixel. Now I'm working today at super fast f4.1, and the new arc second per pixel it's 1.17. If you come here to this table, if you want, I send you by email. I send already to some people that asked me this file. I come here with this value, arc second per pixel. I have here the sensor 463, and I know that now I have 117. I come here, the sensor at the left, 4.5, it's more or less there. And I have 117. I have here 116. It's more or less there. And you can see I'm in the red zone. It's the good zone, the brown zone here, or orange. This is where I want to be. I was here at the right. I was oversampling. So my stars tend to be bloated. Even with the infrared cut filter, which is essential to get the stars sharper, this will even boost that. And now in this f4.1, it will be everything sharper and brighter. It's very, very nice. And with, for example, 4-second exposures, I will gather the same information of 8 seconds. I will, more or less. So you have here this. If you want to use it, just tell me. Now I will connect the telescope. Okay, now We have strong wind, incredible. I will show you a site that is very nice for you to use. You probably know already, some of you. It's this one. Wind. It goes to my region. It's this blue dot here. You see the wind? When it's green is bad. When it's orange is horrible. I'm getting more orange now. When I placed the telescope outside, it was green. This is Meteo Blue, the site. It's very nice to watch this. Okay. So I have in the problem will be we will surpass that, because that's why I choose the 8-inch. It's much more easier to balance. I placed the tarp. It's not doing too much, but it helps. And also using a trick, it's to point to south, and as the eagle is and the Sagittarius constellation, and so it's more or less south, or almost. It's not south, but it's southeast or something. It will be it will not impact so much in the image. Now you can see that I have loads of coma at the edges because I'm using that cheap focal reducer. With an Nexus, this don't happen. It's only happen with the cheap focal reducers. If you try a focal reducer with your telescope, if you get focus, you have to place it near the sensor to get focus, and then you try to extend, and you will get this. The more you extend, the more you separate the focal reducer from the camera, the more coma you will have. These aberrations this is like effects from the curvature of the lens of the focal reducer. So what I do is I will use that trick that I made a video about. I will use the ROI, the region of interest, which means only this square at the middle will be used by the camera, and it will cut all of the edges out. And this is okay for small objects, and the eagle, it's not very small, but it fits in the area, the capture area. So now I will open Stellarium. Okay, it's the software I use. It's very nice. And for the people that don't know, I use Stellarium with a free push to software. It's ASCOM to tell me where the telescope is. I pointed already more or less above Sagittarius. I will show you. Hold on. Stellarium. So the thing is not very good because of the wind. But I pointed more or less. This is Sagittarius here. You see loads of objects here. Sagittarius here. And the eagle, it's up. I was pointing to the Trifid. I had a mistake. It doesn't matter. The eagle is here. I will press Ctrl 1 and the pointer will go there. See? Very nice. This push to system for free. I don't need nothing more. So I will try to plate solve. I don't know if it's too distant. It has to be near. Hold on. Sharp cap. I open sharp cap again. I go here to the right and here. Plate solve. If it's more than 15 degrees away, it will not plate solve. But I point it again. Let's see. Let's wait just a few seconds. This is good because we can point more or less to the place. And even you see the stars are moving a lot because of the wind. It's strong wind. This will make only that will be more rejected frames, but we will do it. And I can't go with long exposures. I will cancel because this is not at the position. Cancel here. So what I will do is point a bit more up. So I have here Sagittarius, which I can see. And I will place the tail rod. I will watch this part of Sagittarius. And I will go up, up, because I don't know if I will see this star here. If I could see it, it was easy. It could be easy. So I will point more or less here. I can see Ophiuchus, so I know more or less this triangle here, this asterism. I can see more or less where it is in the sky, and I will just point the tail rod more or less here. Hold on. I did another trick to find it, which is when you have light pollution and you can't see. Now I'm without dark vision, so it was my problem now. Let me just hide this. And you can't see the... I was expecting to see this constellation and this constellation I was not seeing, so I came here to watch Antares. So watching Antares, that I can see it's so bright, you can do this trick to find objects and with a tail rod. If you notice, it's more or less in the line of Antares. So it was my point of reference to know the place where I was pointing the telescope. Little tricks that if we use, we can do the things better. Now, let's see where we are, if now we have luck. Plate solving, this little button here. This software is great, even with these aberrations, you can see, and even with this shaking a lot because of the wind, you can find where it is pointed, the telescope. I hope. It's a lots of wind. Lots of wind. Look. Let's see. Or maybe I pointed in the wrong place. It's getting hard. I can look with a finder also. It's an easy... Oh, he found. Okay, he found. It's green here, that's because it found. Now, what happened is, now it pointed the brown pointer to the real place where my telescope is. Okay? So the eagle, it's here. Look. I will change now from the tail rod to the camera. You see? This is the ZWO294. With the focal reducer, we will get more or less this. It will fit all the sensor because I will use the ROI. No, the telescope is not this one, is the 8-inch. It will be like this. It fits. Not all, but at least the central part, the pillars of creation. Not with the Nexus, with the 0.5. Okay. It will be less than this. 0.75. Also like this. Okay, this is more or less. And I know that I just have to point to the left. So I will go outside and point the telescope, move the telescope to the left. Let's see if we can find. I will do another trick, which is the auto stretch here. Bam! You see how greenish. But I will lower this bar here. Here, I'm here. to get it softer. And hopefully we can find the nebula green. Hold on. Now I'm trying to centering the nebula because I'm using the ROI later. And as I'm going to use the ROI now, I need to have it centered. Otherwise it will be cut. You see? This is without any procedure. Now what we are going to do, I will use only 4 seconds. You see that is moving a lot. It will reject a lot of frames. But as I use another trick, which is the filter, when this shakes, it will be rejected by the software. I will show you. I always show all these steps. I break down all of these steps for the beginners to start watching and learning, and for the experienced guys not to forget and remember to do all of this. It's all the same, always the same. So I will use the 4 seconds with reducer. FR. It's this. You will see this will shrink. You see the field of view? Now, autocolor, always the same. Autocolor down. And here, auto stretch. And look at the nebula. Bam. You see, I didn't center very well. It cut here the top, but it doesn't matter. This is just to not to be perfect, but to break down the process and you to see how it works. And it's beautiful anyway. Now look what I'm doing here at the histogram with the bar at the left. The left side of the histogram is the black side. The right side is the white side. And these waves, we will adjust this bar at the left, the black level, it's called, to the middle of these waves. You see the image already improved. It's stacking. 15 stacked. Very well. 15 4-second exposure. Now, the mid level, the right level, the white one at the right, I don't touch it. Usually. The mid level, I will slide it to the left. Look, it's getting brighter, but I can't push too much, otherwise it will blow the image. You can see, look, too much noise. Later in the stacking we can push a bit more and a bit more and a bit more, because during the live stack this will clean all the noise that you are seeing right now. Unfortunately, with my poor tracking, I can't stand too long, but anyway, I don't stay too long. I go maximum 20 minutes maybe. Now, this will keep this at the middle. The middle level we push a bit just to enhance this. Now, what I always do, first I will correct the colors. These waves, I will zoom for you to see. I'm watching the green, too much green. Hold on. Too much green here. We have to crank down the green. I will show you with a zoom. Look. You see? The green is too much to the right. We want to align all of these waves with the white. We want to align the green, the blue and the red with the white. Usually. Sometimes we push a bit more of one of them, usually the blue or the red, to adjust. It depends of the object. So now I will go to the green color at the bottom right and look what happened. The green is cranked down, and at the same time, look, I have to show you like this. When you move any of the colors, usually moves the other colors. So when I lower the green, if I crank up the green again, you see? So sometimes we just do a little bit of touch in the other colors. For instance, I crank up the blue and crank down the green. No, I crank down the blue because it's too up, and the red and the green to see if it stays better. It's more or less the same. It's what we have. Usually it's the thing affect the colors and the filters also, but it's okay. We want the green to be aligned. We prefer the green to be aligned because of the greenish tint we have from the light pollution and the seeing, the turbulence, whatever the wind is blowing away, all the dust. So we prefer to have the green lower and the blue and the red a bit more to the right, as we can't place it all together. So in this situation we choose this. Now the color is done. We take the opportunity to adjust here the bar. Okay, we uncheck the zoom and look, it's getting a perfect, like a mountain or an iceberg. You see? Now I go to the enhancement tab here, and as I always do, the bilateral filter checked, and the unsharp mask in this nebula may work. I will check. It will get it will turn the stars brighter, and some galaxies get brighter also. The objects get brighter. If I take it off, look what happened to the stars. That depends what you want to see. Sometimes we check the unsharp mask. It gets everything. It turns everything sharper, but it increases a bit the noise. So it depends on the object. In this case, it didn't affect so much the noise. So I will rely on the software during the live stack to get rid of this noise. One thing I use to control the colors at the background, because they change with the seeing, with all this movement with the wind, or even the focus sometimes change, and the colors changed at the background. If they change, I will readjust. It's very nice to do this. Look at the nebula is so fine. I will zoom like making control and the wheel of the mouse. Control and the wheel of the mouse pointing to the pillars of creation. Look. The reason I like to use the focal reducer, even this cheap one, is because it's getting faster and everything is so much brighter. If I wasn't using the focal reducer, this wasn't so bright and so sharper. See? And the more we stack, this is only 4 seconds. I can't go more. I usually do 8 or 10. seconds, but today I can't. If I do a live stack with 8 seconds, the stars will be elongated or will be cut and rejected by the filter I use, and I will going to show you. The filter I'm using, and I always use, is this one. Full width, half maximum. This is the width of the star, more or less that. And as you can see, the red ones are being rejected. When the wind came, they reject it. Okay. Beautiful, this nebula. Let's see it with less zoom, which means we will have less defects in the image. I will do the auto here. You see it's cutting here and at the right. This means, for the people that have or want to have an equatorial platform, this means the platform is moving the telescope, is moving the object is moving up and to the right. The telescope is moving down and to the left. Usually we change the speed to adjust this. As I am in pointing southeast, more or less, the object is doing like this to the right. If the object is now going to the right more than it should go, that means my telescope is getting behind. It's slower than the sky, the telescope with the equatorial platform. So if I crank up the speed a bit, it will catch again the movement of the sky. This is very funny too, and helps us, this platform, the equatorial platform, helps us to assimilate the movements of the sky. We look at the sky and we know everything, it's there, and we know intuitively the movements they will going to make. It's funny. Let's see the shot. Okay, this I saw. Let's see here. Carlos, I want to buy my first camera, ZWO AZ120 MS. Don't buy the 120, please, Carlos. Buy the 224 or the 290. Because the 120 has an older, it's not so efficient, basically. The difference in price that you pay for the 224 or for the 290, it's much more valuable than, how to say this, the difference in price, it's good. The 120, it's not worth it. It's worth it to pay that bit of difference in price. Then between the 224 or the 290, you can choose. It's more or less the same. I think that yes, the 290 they produce already yet. I think they produce it. I think the color one it's produced yet. Anyway, then you look to choose between the 234 and the 290. You look at the pixel size and use that trick that I do with the Excel formulas, the arc second per pixel. So if the 224 I think has a larger pixel size than the 290. I think no, I know because I bought the 224. Having a larger pixel size, it's better for my setups because of that undersampling and oversampling thing. Basically the oversampling. because if you use the 224 is better with a larger pixel than the 290 for the Dobsonians, like these ones that I have. Look, this is cutting. This is cutting the image because of the tracking. But I will not touch. I will do it again with other object. We do like this. So don't buy the 120. No, I didn't move. I moved the mirror with the 12-inch Dobsonian. I moved the mirror. I upgraded for a low profile focuser. And hold on, I didn't. I have to place this. I was looking to the 12-inch and I didn't place the cap in the focuser. And is getting with dust. With the 12-inch I made all of those modifications and I can use anything. The Nexus, I can use the series on the Nexus. But with I will explain why this is very important. Great question. I will explain why I didn't move the mirror, and I will not move the mirror in the 8-inch f6, because the 8-inch f6, my 8-inch f6, has a smaller secondary mirror than what I have in the 12-inch, which means you know that a reflector do like a cone, no? The light, the photons come to the primary and then do like a cone to the secondary mirror. When I move the cone up, we move the mirror up, the cone will go up, so it will grab a larger area in the secondary mirror. In the 12-inch, moving it up, the size is okay of the secondary mirror. It will grab all the light because it's large. In my 8-inch f6 I'm using now, if I move the cone up, it will cut the cone. So what happened? It will be the photons will come from the sky, will bump in the primary mirror of my 8-inch, will go up in cone because the mirror is concave. I think it's the right word, and it's curved, and that's why it makes the cone, and it will bump into the secondary mirror, but not the edges of those photons. Those photons at the edges will go up to the sky again, to the universe. So it's not good. I don't want to cut I want to grab all the photons. I want to maximize always, I want to maximize always my setups to have good image. The secret of my setups are that little things all together. It's not one thing, it's all those little things. I moved for back focus, but I will not move in this case. In the 8-inch, I don't need the back focus because I don't use the focal reducer at 0.5, which is the focal reducer. I use it now, it's at more or less 0.7. It's the trick. This is full of tricks. When's that Pluto video? I'm waiting for it. I'm waiting for a better opportunity in Pluto. Maybe, I think I saw maybe after the next full moon or in the next new moon. I think we will have I will do it a video, but I will do it here live also. Chris, you ever look at the small star cloud, my absolute favorite? Sometimes I point there. Sometimes, sometimes I point to the black hole, but I don't see nothing. But I like to point there. The A. Now let's see what we have here. Let me see the stack. So we have two. Oh, it's stacking. We have 240 stacked. 16 minutes. It's doing fine. With 4 seconds, it rejects only 10 frames. You see the trick to the wind? This is full of tricks. Full of tricks. Now, let's see what we have here in Stellarium. We have the Omega. I didn't see it this year yet. The Trifid also didn't see it. I saw the Lagoon. Where is the Trifid? It's near. Where is the Trifid? It's here. Let me. Trifid. The lazy way. Trifid. Trifid Nebula. It's over the lagoon. No. Yes, it's over the lagoon. This is the lagoon. It's at 26 altitude here. Maybe we can point to the Trifid. It's beautiful, and it fits also the focal reducer, I think. Let me see. Yes, it will fit all the screen. Let me see again. So Telrad, it will be this star of Sagittarius. It's easy because I can see Sagittarius. I will point to the Trifid Nebula. It's very beautiful. Those colors. That's why it's worth it to have a color camera, I think. I don't like the mono. You see, it's cutting. Look at the poor tracking I have. It's cutting all the to the right. But at this time, I was already finishing the session with this object. Let me see the histogram. We can see the pillars of creation more sharper now. If we just want the pillars of creation, we can have it. Look, with the 8-inch, it's very nice with an 8-inch. So now I will restart this. This is the nebula here. And I will try to point to the Trifid, which is... Okay. A bit down to the left. Hold on. Start hoping. Look at the Milky Way. Beautiful. Portal 5. Let's see. 2-second exposures. 4-second. Let me see with 4-second what happened. A bit greenish. This is not live stacking, nothing. This is only pointing the camera there. Beautiful. Now let's see, let's plate solve this. Oh, it's there. I pointed to the place. Wonderful. I will recenter. I will center this here because of that trick of the focal reducer and the ROI. I will center. I will just boost a bit here the mini histogram. I will just slide this bar, middle bar to the left, and this will be brighter because I'm outside and I can see better the screen. I'm watching in a television here. The image is huge. And if I remember, I will adjust the speed to catch the object, so I will crank up the speed a bit. I will take the opportunity and adjust. Now, to do this that I was doing, it's very fast. You saw that I did it very fast. The trick is to have your Dobsonian smooth, not too smooth, not excessive, and not too tight. You get that balance in the altitude bearings and in the azimuth bearings. Now let's live stack this with a trick. 4-second, of course. I adjusted the speed also to see if it gets better now. Let's see. Oh, it's wrong. I didn't the trick. FR to 4 seconds. Look at the wind. It's strong, the wind. But I'm happy because clear this mess. Because I know with this live stream I've learned that I can do live streams with wind if I point south and use only the 8-inch Dobsonian. It's very strong, the wind, you see. Look at the stars. This is the wind. I'm clearing. What I'm doing is resetting until I find... Look at the stars. Okay, this one is okay. This one is okay. Now, histogram, color, auto color, ping. Auto stretch. Bam. Adjust the histogram again. Always the same. This is always the same. We nice and steady. I taking more time here because I want you to learn. 4 seconds are not working because of the wind. I have 2 seconds also, but the image will not be so fine. I will reset. If we reset now, after moving the histogram, adjusting the histogram, it will stay like this. The color, everything. It will keep the histogram. Wrong. Too hard today to wrong. It's the wind. Okay, I will leave it like this. I will be forgiven. I will be forgiven to tolerant with the stars to see the nebula. I will not reset now. Beautiful. Even with, you see the beautiful thing that EAA and with the Dobsonian is. Even with all these problems that I'm struggle with, the wind, strong wind here, the speed to adjust, the necessity to, the need to lower the exposure time. Even like that, we get a beautiful picture in just a matter of seconds. This is great. Now let's watch the histogram again. Control this, crank down the green, just 1 tick, 2 ticks. I will push a bit. The filter I'm using, the Bader infrared cut filter. Just do that, just cut the infrared and the ultraviolet waves. It's very nice to watch this, and the Bader neodymium also. It stays it leaves these dust lanes here, you see, of the third. These are 3 sections. The third one here, the dust. The brown is the dust. The red is the hydrogen. And this area, the blue, I think it's the oxygen. No, I will confirm because I don't want to say anything wrong. So, tree feed. I go to Google. Let's do it with you. We go to Google. Tree feed nebula. Tree feed. Let's see if it says here. Oxygen. Hydrogen. Hydrogen, it's the red. I like to do also this. Tree feed, nebula, NASA. Look at the pictures. Because it's a trustable source. These stars are releasing a flood of ultraviolet radiation that dramatically influences the structure and evolution of the surrounding nebula. Star formation is no longer occurring in the immediate vicinity of this group of bright stars, because their intense radiation has blown away the gas and dust from which new stars are made. Incredible, I didn't know that. They blown away the formation of new stars. But it's beautiful. You see the dust lanes? The more we stack, the more the dust lanes will appear sharper. It's a beautiful nebula. Let's control the histogram because this is weird today. Okay, to the left a bit. It moved a bit to the left. This peak, the peak of the histogram, sometimes it moves to the right or to the left. Now let's boost a bit the mid-level. Now. And we can see more detail, even more detail now. This is the Dobsonian power. I should crank up a bit more the speed, it's still going to the right. I'm watching here a black bar. This means this area, or all this area, this bar in the right, is not being considered in the new stack image. It's lost. Here it's lost already. But we usually cut this. I'm using the ROI, for the ones that don't know, which means this area here at the right. This is amazing. Now let me take this out. This is amazing. Using this trick with a ship focal reducer, I'm using just this rectangle. The camera is using just this rectangle, but by the opposite of the using binning, these pixels will remain the same. So we have the same quality if we use all of the sensor or if we use just this small area. The quality is still there. Better because it's getting faster with a small area. The transmission of the data between the camera and the computer is even faster. It's very nice, this trick. You should try it. You get a faster telescope for $50. It's nice. Let's zoom a bit. Control and mouse wheel. Let's see again. The NASA. I like to gather information because there are so many objects in the sky that we usually forget. Oh, nice. We can read and at the same time. Let me see the most important things. This is the way they capture it. Sagittarius. Not much information. 9,000 light years away from Earth in Sagittarius. They are forming stars. This is an image, a zoomed image of a star formation area, which is in the hydrogen. Yes, they are not forming here, from what I understood, in the blue. And in the red, it's hydrogen, they are forming stars. At least it's what NASA says here, so we trust. The red represents hydrogen and sulfur, while green represents oxygen here in this Hubble image. Okay, I want to tell something that someone asked me also. It's about the vignetting. Look, it's messing now the image. I will like this and hide it. It's about the vignetting using the Arizona Nexus. If I do this, I probably will see the vignetting. It's cranking the mid-level all up. No, I'm not watching vignetting because I'm using the ROI. But when you have vignetting here and you don't do flats, I don't, you just crank this bar, the mid-level, to the right, and it will soften the vignetting until it will disappear. It's the trick. That was a question from Pattison. And also, if you don't know how to do darks, you have now a new feature in the Sharp Cap. I will cancel this. You have a new feature. I don't know where it is, but it's look at the wind. It's the wind. The wind. It's not helping. It's hot pixel suppression. Hot pixel suppression. For the people that don't know how to do darks or it want to learn but not yet, you can use this hot pixel suppression instead of the darks. It will not work so good as the darks for the background removal, but it will remove the hot pixels, which I don't have because I've made darks for this ROI. I had to make darks. I made darks for the larger screen, the larger area, which we are watching now. The Nebula is smaller, and I made darks for the focal reducer with the ROI. We have to do that. Even like this we can see the Nebula here. Incredible. So thank you very much for being here. I wish you a very nice week, and we will keep doing these live streams to keep you in touch with the sky and connect with the sky in a better way. Thank you very much, and see you in the next live stream. Bye bye.